Hello, welcome back to my channel Networking with Neaz Arefin Onu. Today we are going to talk very shortly about what is VPN. To comprise the definition of the VPN is to provide integrity, authentication and encryption. Suppose you are traveling to a different country and you have a transit and you have to use a unknown network. What you're gonna do? You have to use an unknown network provided by the local airport. Or you are at home and you want to access your bank. Now you definitely do not want to share your bank credentials, all the login information that has been provided by the bank. Somebody in the middle spying on you and taking all that information, and then they can hack your account or can take access over your information. So VPN comes in the middle saying that, hey, I can give you a private channel. You guys can talk in between privately. Nobody is going to take access on that. And don't worry, whoever you authorize, only they can use that tunnel. You guys will have some secret keys to hear each other. VPN is actually trying to hide your data and your identity. By name, there's a lot of protocols that we can talk about. There is IPsec VPN, and then we have a layer 2 tunneling protocol, which is known as LT2P. Then we have generic routing encapsulation, which is GRE. Kind of obsolete. People and companies, they don't use that very often because that is not secured and they do not provide data encryption. The whole purpose of the VPN technology is to secure your data. VPN means virtual private network. It is logical, it's not physical. As I have mentioned before, I'm not going to dig deeper what is VPN exactly and how that works. The main purpose of making this video is to configure a very popular type of protocol known as IPsec VPN
in main mode and aggressive mode. In IPsec VPN, they uses two methods for data encapsulation. What is data encapsulation, by the way? The data encapsulation means adding a header, data, and the trailer. That is called the data encapsulation. There's two types of encapsulation. They do use an IPsec VPN. By default, the router chooses the tunnel mode, and then there's transparent mode. In tunnel mode, everything is encrypted. In transparent mode, only the payload, the core data, is encrypted. Everything else is plain text. Now, in IPsec VPN happens in two phases. IKE phase 1, where is the isakmp, and then IKE phase 2, where is the IPsec, the tunneling. The main security is in phase 2. The phase 1 is just a proposal. Okay, so the phase 1 has to be configured in two mode. One of them is main mode, the another one is aggressive mode. In main mode, there is a router who initiate the proposal, and there are another routers who are the responder. So somebody proposes and somebody accepts it. Router 1 sends an IKE proposal, responder kickback with that proposal acceptance. Then he again proposes a Diffie-Hellman exchange, that's a key, and the responder accepts the Diffie-Hellman exchange. Again, they propose the authentication request. The responder accepts that authentication acceptance. In total, in main mode, they exchange 6 messages, whereas in aggressive mode, they exchange only 3 messages. In phase 2, they use only 3 messages where the tunneling happens. We'll go one by one. First, we'll configure the main mode, and then literally we'll configure the aggressive mode. We have some criteria here, some requirement. Our goal is to protect traffic between 1.1.1 and 2.2.2 using the following policy. For IPsec VPN, we have two phases. In phase 1, all the policies and the proposals are proposed to a responder. The tunneling, the IPsec policy, happen in phase 2. We are going to accomplish our goals in 6 steps. The first goal is to configure the parameters for phase 1. Second step, configure the parameters for 2. 3, define the traffic that will be encrypted over the tunnel. 4, configure a crypto map to link phase 1 and phase 2, and then apply the crypto map to outgoing interface. 6, deploy a default and a static route to over the router. We have 7 networks here. 3 of them are configuring the 3 routers, and then every router has a loopback interface. This is a cloud for router 1, loopback 1, router 2, loopback 2, and for router 3, loopback 3. And for router 1, we have 140.1.14.1, for router 2, 24.2, for router 3, 34.3. They all are /24 mask. So this is our topology. Let's bring all that console. Do clear log. Do show run section IP. We are going to configure the phase 1 right now. So for phase 1, our configuration is we need a authentication method, which is pre-shared key. That is our requirement. Yes, okay. Configure the confidentiality. That is the encryption. And there is a lot of encryption method, but we are going to use 3DES. DES stand for data encryption standard. And 3DES is 168-bit long. And then third, we need a Diffie-Hellman group, and we are going to use the group number 2. And also we need a cipher method, which is the hashing protocol. The hashing method will be MD5, message digest. Now these are the actual configuration that I'm going to do here. So let's go line by line. The first command will be crypto, and then we're going to take help. As we have said before, that for phase 1 we need the isakmp policy, and in phase 2 we need the IPsec. So crypto isakmp, and then what we need policy. Here you see that PR profile, a lot of things we are going to encounter, but we need policy, and then I have to give a name to the policy. You see here the number should be between 1 to 10,000. I'm gonna do 10. The second thing that we need is the encryption, and if I take help, okay, so you see the encryption. There's a lot of encryption. There is 3 days AES and then DES, as I told you before. Our requirement is we have to use 3 days, so 3 DES. Okay, and then what next? We need a hashing protocol, and we have to use MD5. What hash we have? I have seen message digest 5, so MD5. Okay, and then authentication. Our authentication method would be pre-shared key. That is our requirement. We're not doing it randomly. This is our requirement that has been given. Hash MD5 is gone, and then we would be in need of authentication. So authentication, what? Pre-shared, our given task. Pre-shared, okay. And then we need to specify the Diffie-Hellman group. Yeah, PFP, and then you see there's a lot of group number. We have to do the policy number 2, as that is our task. Diffie-Hellman group 2, and then we have to define the key. If you see that goal again, our key is SVPN 30730. That is our pre-shared key. We have mentioned the pre-shared key before. That is our authentication process here, but we actually not been defined the key. This is the pre-shared key, but actually this is the key. So we have to mention here now, so, crypto, and then isakmp, and then key SVPN. Now I have defined that key, address 140.1.24. Okay, now wait a second, why that address is here? What does that address mean? That address means I'm telling router 1, you're only going to accept that packet if that packet is coming from that IP 141.24.2 with that key. What is the key? SVPN 300. That means this router needs to be configured with the same key as well. This router is the initiator and this router is the responder. Okay, so we have configured the phase 1. Now to verify, what would be our command? Do show run section crack. Yep, there you go. So this is our requirement for phase 1. What is that? Crypto isakmp policy 10, encryption 3 days, and hash MD5, which is our hashing protocol. Authentication method is pre-shared. Diffie-Hellman group is 2, and then this is our key to define that key. Phase 1 is done. Now we are going to go to phase 2. This is our phase 2. As I told you, in phase 1 the policy are being exchanged. Router 1 is proposing R2, hey, I need to configure VPN with you and I have this, are you gonna agree? And then this router is gonna say yes, I do agree. This is the phase 2 where the IPsec happens. And what is the requirement here? As we know that IPsec happens in phase 2, not in phase 1. In phase 2 we have to define only 2 things. What? Encryption ESP, encapsulation security payload, and again our method would be 3 days as phase 1, and the hashing protocol is MD5. Okay, so let's do crypto IPsec. We have done isakmp in phase 1, and here it should be IPsec, crypto IPsec. And then if you take help, you see a lot of things here. Transform set. What is actually the transform set? VPN proposals, also known as the transform sets, are a set of protocols and algorithm. Basically the hashing protocol, everything that we have been done, that is called the transform set. It's a framework. If I take help here, it is now asking me to give a tag. Tag would be SVPN. And then what? And then it is asking me to choose the encryption method. As I told you, we are going to do the ESP MD5 HMAC. HMAC stands for hashing based message authentication code. We are going to mention ESP and then MD5 HMAC. It says here proposal with ESP is missing cipher, so I'm missing something, right? here I should mention ESP and then 3 dis. There you go. What is our third step? Define the traffic that will be encrypted over the tunnel. That means we have to create an access list, as our given task is protecting traffic between the loopback 1 network and the loopback 2 network using the following policy. Access list, and then I'm going to do the extended access list, not the standard one. So I'm going to name it 101 IP host 1.1.1.1. IP host means that's the source, and then host 2.2.2.2. Finish. Our access list configuration is accomplished. This host means the destination. So what I said, that traffic from 222 to 1.1.1.1 is permitted now. There you go. This is our access list. Do show run section access list. Okay, now move on to the step 4. Configure a crypto map to link the phase 1 and phase 2 parameters to each other. As of now, we have configured 3 steps, but they all are individual and have no relations to each other. Now we are going to establish the link between 1 to 3. Mapping means linking or merging. So what I'm saying, create a link between all these 3 configuration now. Defining the traffic, that means the access list, and phase 1 and phase 2 as the ISAKmp policy, and then the IPsec. We are going to merge all them. How do you have to merge it? Crypto map, and I have to give a name, cmap 10, and then I'm saying IPsec is going to be merged with isakmp. Okay, and now yes, now see the note. You have to read the syntax very carefully. This is a new crypto map. This new crypto map will remain disabled until a peer and a valid access list have been configured. By just creating an access list doesn't mean that this access list is now in action. So what I have to do, well, we have already done the configuration. I just have to assign in an interface. And then what is the first message? This new crypto map will remain disabled until a peer. What is peer? Trusted device. So I'm going to tell router 1 that, hey, you are going to trust this device now. You're going to pair with R2. I have to configure the peer now. Set peer 140.1.24.2. I have done exactly what I've said. And then set transform set. And what was the name of the transform set that we have just given? SVPN. And now what I'm telling, 101 is the access list that we have just created in step 3. Now I'm asking to follow the access list. Okay, match address 101. Okay, now this is our final step. Apply the crypto map to the outgoing interface. Now interface serial port 2 by 0. Is that so? Yes. I'm gonna say crypto and then map c map. There you go. You see the message on May 9th. This time crypto isakmp is on. So I have just applied that crypto in an interface. Now 6, deploy and a static route to every router. I don't have to do that, as I mentioned you before. I have already done that before. Alright, everything has been performed on the router 1 or IOU 1 that needs to be performed for IPsec. I have to do all the similar stuff to the router 2. As I have said before, the router 1 is going to be the responder for site-to-site IPsec VPN. One router will play the role for initiator and the other router is going to be the responder. In this case, the IOU 1 or router 1 is the initiator, he is proposing, and router 2 or IOU 2 is the responder, he is accepting. What about the protocol, hashing, encryption, secret keys, the transform set, everything he will be giving to him. He will accept all that protocol and send back to him again. So we have finished with router 1. We will configure the same in router 2. So I'm not going to type in manually in router 2 to save the time. I have pre-configured a prompt. I'm simply going to copy from here and paste it. Couple of changes that we need to do is just the address, source and destination. It will just revert, and the source in that case will be the destination. If you see the diagram, in that case that will be the source for router 2 and that will be the destination. Simple. Again, the peering, set peer will be changing The set pair will be 141 because in that case router 2 is setting the pair with router 1. So the IP address for router 1 is again 141.14.1, which is exactly here. 141.14.1. Everything else is the same. It has to be same, otherwise the IPsec will not be established. The same crypto ISAKmp policy 10, encryption 3 days, hash MD5, authentication is a pre-shared key, and the difficult element group is 2. Crypto ISAKmp key, that is define the key thing, and then the address is 141.14.1. So for router 2, this is the pairing device. Also match address 101, interface S2 by 0, crypto map CMAP has been applied. I'm just gonna copy this. I'm just gonna paste that. You see, now R1 should be able to ping R2 as they have routing protocol as well, the static routing protocol. Ping 140.1.24.2. Yes, it is pinging. If I ping from the loopback interface source 1.1.1.1, yes, it's pinging. Well, if I ping from loopback to loopback, yes, it's pinging now. Now if I go to router 2, if I say do show crypto IPsec SA, now we'll be able to find out packet encryption 19, packet encapsulation 19, packet digest 19. The same way, packet decryption 19, packet decapsulation 19, packet verify 19. And for router 2, the remote device will be router 1, so the IP address will be 140.1. So this is one of the command that we can verify the IPsec has been established with router 1. Now there is some verification command that we can execute to see what's going on there. So in router 1, if I say do show cry as I can say, cry means crypto. Cry is the short form of crypto. So destination is this, source is this one, QM idle. The QM idle should always be idle, and then the connection ID status is up. As I have finished establishing the IPsec VPN between router 1 and router 2, now it is very important to know some verification and troubleshooting command. First command, that would be do show run section crypto. Once I hit this command, you will get a message box like this. It shows the phase 1 that's needed for the isakmp configuration, also shows the phase 2 that's needed for the IPsec configuration. Number 2, do show crypto map, name of the crypto map, mapping configuration, which is like this. Now third command, do show crypto SA identity. We are searching by identity now, shows to whom the connection is happening. So if you see here IOU1, that means router 1, that is the local identity, that's the remote identity. Current pairing is 24.2, that means router 2. So router 1 is pairing with router 2. Number 4th, do show crypto isakmp SA, shows destination, source, state, QM idle, always should be idle, that means the state should be always QM idle and it should be active. 5th, do show crypto IPsec SA address. We are now searching by the address. Again, I am in router 1, protocol ESP, pairing with 24.2, which is router 2, security parameter index, that is the ID, SPI ID is 1532448934, that's the remote IP, which is router 2, SPI ID is this one. There's another command, do show run section transform set. We have discussed before what's the transform set. It's a framework, that means it's a lot of configuration together that we call transform set. You see that crypto isakmp transform set SVPN, we have given the name SVPN. There is another command, do show run section access list. It will show you running access list. Do show run section mapping, will show you the mapping. Crypto map CMAP 10 up. We have given a name CMAP. The mapping means linking. We have discussed that earlier, and that mapping we have given a name which is CMAP. That's the ID. What have we mapped? We have mapped the IPsec with the isakmp. ISAKmp is the phase 1 and IPsec is the phase 2. So we have mapped the phase 1 with phase 2. Matching address 11. What is 11? 11 is the access list that we have created. Crypto map CMAP, that has been applied to an interface. In aggressive mode, we really do not need this command. If you guys remember the prop that we configured for main mode, here is that. We really do not need this command. Crypto isakmp key SVPN 30730 address 141.24.2. We need everything else but not the key. Rather, we are going to say in aggressive mode, crypto isakmp peer address 141.24.2. The difference starts from here. In aggressive mode, literally 3 commands that we have to add more in the aggressive mode. That's the only 3 commands that is making the difference. Soon after we give this command, we have to say set and make sure we are in the isakmp pairing mode. Okay, once we say set, then it will give us option which mode you want to configure. Then you have to mention set aggressive mode. Now remember, by default it chooses the main mode, it doesn't choose the aggressive mode. So by giving the command set, you have to mention that you want to configure the IPsec VPN in aggressive mode. After you give the command aggressive mode, if you question mark again, it will give you 2 suggestions: client endpoint address and password. Remember, we have not put the password here. In main mode, we have mentioned the password here. Rather, we are going to mention here. We are going to say set aggressive mode client endpoint IPv4 address. It is the IPv4 address, that's why we are saying this. If it is IPv6 address, then we are going to mention the IPv6 address. And then we are going to mention set aggressive mode password SVPN 300-730 that we mentioned in main mode here. I'm going to show you the complete prop. Literally, these 3 commands are extra in aggressive mode. You just have to manipulate these 3 commands. Crypto isakmp peer address 141.24.2. We just have taken out the secret key from here, which is SVPN 300-730, and then set aggressive mode. You just have to mention which mode you want to configure. And then client endpoint address, which is this one. This is IPv4 address. And then set aggressive mode password. The password that we have taken out from here, we have to mention here. Set aggressive mode password SVPN 300-730. Whereas in main mode, it needs only 1 command instead of 3. What is that? Crypto isakmp key SVPN 300-730, the secret key, and then mention the address. See here, crypto isakmp key SVPN 300-730 address 141.24.2. That's the address for router 2. That's the only difference between the main mode and the aggressive mode. The main difference is the messages. In aggressive mode, in total they exchange 6 messages, 3 in the phase 1 and 3 in the phase 2. So 6 versus 9. Also, I would suggest to go by the link that has been given below to check what type of messages are exchanged in main mode. So in main mode, they exchange in total 9 messages. In phase 1, they exchange 6 messages, and phase 2, 3 messages. Once you click the link, it has all the snapshots that will give you better idea. In aggressive mode, they exchange in a total 6 messages. Thank you. If you have any question, please let me know by comments.